Alright, class. So today we want to look at under vector algebra the dot product. The dot product. So in other books you will see what? Scalar dot product. In other books you see scalar dot product, or you will see inner product, or you will see inner product. Alright, so they are all the same thing. So you see that you are seeing dot product, the scalar dot product, or you are seeing what? The inner product. Alright, so now with the dot product of vectors, let's consider a vector A in three coordinate system, and a vector B, B1, B2, and B3. They are all in the 3 space. If you have vector A and vector B, then we can say the dot product of vector A and B, the dot product of A and B is then equal to A dot B, which is given by A dot B equal to A1 multiplying B1 plus A2 multiplying B2 plus A3 multiplying B3. So now what you should understand here is that anytime you are done with a dot product, you don't have a vector again, but you have a number or a whole number. Let me say it that way. Alright, so for instance, let's look at this vector 2, 4 in a dot product with 3, -1. So you have these two vectors. I want to find their dot product. So what happens is that, so let's assume here is A1, here is A2, B1, here is B2. So therefore the dot product, which is vector AB, is then equal to 2 times the 3 plus the 4 times the B2, which is the -1. So when you do this, you are getting 6 minus 4, and that will give you what? 2. And that will give you 2. The same way, let's try another example here. 2 vectors, -1, 7, 4, in a dot product with 6, 2, -r. 6, 2, -r. So now what happens is that your dot product A to B, if this is vector A and this vector B, will give what? -1 times 6, and the second one plus 7 times 2, and the third one plus 4 times -r. Alright, so now when you do this, what are we getting? You get -6 plus 14 plus 14 minus what? 2. And when you calculate the whole of this, you get what? 6. You will get 6. Alright. So now having this understanding, let's look at the properties of dot product. Let's look at the properties of a dot product. The properties of a dot product. Alright. Now when you have it, if you have 3 vectors, and let's say the vectors are A, B, and C. You have 3 vectors, and let's say the vectors are A, B, and C. And these vectors are in the Euclidean 3 space. All these vectors are in 3 space. And let's say variable C is a scalar. So this is the preamble to our properties. So now the preamble to our properties, you want to consider 3 vectors A, B, and C. They are in what? The 3 Euclidean space. That is to say, they have the 3 coordinate system. And C is a scalar. Then the first property states that 1, if you have the vectors, the same vector in a dot product, if you have the dot product of 2 same vectors, it is equal to what? the square of their magnitude. If you have two same vectors in a dot product and want to find their dot product, it is equal to the square of what? Their magnitude. The square of their magnitude. And you know how to find the magnitude of the vector. This is how you find the magnitude of a vector. Which is what? A1 squared plus A2 squared plus what? A3 what? Squared. So now, if you have this vector, which is A1, A2, and A3, and they are in a dot product A1, A2, A3. It says that when you find their magnitude, which is A1 times A1 plus A2 times A2 plus A3 times A3, you get A1 squared plus A2 squared plus A3 what? Squared. That will be what? Their dot product. So now in the same vector, in the dot product, this will be the final answer. So when you find the magnitude of what? A dot product, and you square it. So this is the dot product. If you want to square it, it will take away what? The square root. And what is in the middle will be, what is in the under the square will be the same as this. So anytime you square the magnitude for the square, it is the same as what? The magnitude of a vector is the same as what? Their product. Their dot product. Alright. The second one, if you have vector A multiplying a vector B, it's the same as vector B multiplying a vector A. It's the same as vector B multiplying a vector A. I think this one you can try your hands on it. That is to say, if you have B dot A, it's the same as what? B1 A1 plus B2 A2 plus what? B3 A3, and that is the same thing. I get it. So they are commutative. They associate each other, or they commutate each other. All right. Now the third property, if I have a vector A that multiplies the addition of the two vectors, then it's the same as A in a dot product with B plus A in a dot product with C. And this also works. You get it? So this also works. Associativity. Their associativity also works. 4. If you have a vector that multiplies 0, any vector that multiplies the scalar or a number 0, it is equal to what? It is 0. If you have a vector that is in a dot product with 0, so that is to say, if you have vector A as A1, A2, A3, and this dot product is to 0, it will give you a 0 because I have A1 times 0 plus A2 times 0 plus A3 times 0, which is equal to what? 0. All right. Let's look at the fourth one, the fifth property. So now, with the fifth property, if you have a scalar multiply a vector in a dot product with another vector, then it can simply also be the scalar multiplying a dot product of the two vectors, or any of them. This one also coming out multiplying in a dot product with the scalar times what? The B. So now you can also confirm this one too. Alright, so now what happens is that if you have C multiplying the A, so you have C A1, comma, C A2, comma, C A3. And this is in a dot product with B. B1, B2, and B3. So now if it's in a dot product with that, then it's very simple as you have C A1, B1 plus C A2, B2 plus C A3, B3. Now, if you want to consider this one to C into bracket A dot B, you first do the dot product first. And when you do the dot product here, you'll be getting something like this. So then A dot B is what? A1 B1 plus A2 B2 plus A3 B3. So now if you want to multiply the scalar by the A dot B, then we'll be getting CA1 B1 plus CA2 B2 plus CA3 B3. And that is the same as what? As this. So that means the fifth rule also holds. Now, with the scalar product, scalar dot product, we want to look at two basic theorems in the scalar dot product, and we bring an end to this concept. All right. So now let's look at the two theorem. Theorem 1. Theorem 1 states that if you have an angle theta, or if theta is the angle between the vector A and vector B, if theta is an angle that exists between vector A and the vector B, then we say their dot product, the A dot B, their dot product is equal to the magnitude of the A multiplying the magnitude of the B times the cos of the angle theta times the cos of the angle theta. So this one property you should know, one theorem you should know. Alright, so now if the theta is an angle between the two vectors, it's an angle between the two vectors. So let's say vector A and vector B, and an angle theta exists between them. And we want to find their dot product. This is the formula in finding their dot product. Let's look at an example. It says if the vector A and B, so this is an example, if the vector A and B have lengths 4 and 6, and the angle between them, if vector A and B have lengths 4 and 6, and the angle between them is pi on 3, and the angle between them is pi on 3. Find their dot product. Find their dot product. Okay, so this is also an interesting question. Find their dot product. So now what is the dot product over here? Or what becomes the dot product over here? It's very simple. So now it is what? A dot B is equal to the magnitude of A multiplying the magnitude of B cos of the angle that exists between them. And when you do this, I think you are having the magnitude of A was given, which is 4, that will be also given. So you get 4 multiplying 6 cos of the angle between them, which is pi on 3. And in terms of radians, if you want to check the pi radian, the degree is 180. So you'll be getting 4 times 6 times the cos of. So if you take 180 divided by 3, you'll be getting cos 60. So now cos 60 is equal to half. So you get 4 times 6 times what? A half. That will give you what? 12. So the adult product will be equal to what? Will be equal to 12. Alright.